Hello students, today we are going to start chapter number 7 quadrilaterals. Yesterday I sent you some properties, hope you have downloaded them. Today we are going to further understand those properties and those definitions. We'll start by quadrilateral. As you have learned before that quadrilateral is simply a four-sided figure in which this chord means four and the lateral means sides. So a simple definition will be that a four-sided figure is called as a quadrilateral. Now if there isn't any property between the four sides or the four angles it has, then it will be called as a simple quadrilateral. Let me draw it over here. I have a quadrilateral over here. So all the four sides, they have uneven lengths, angles, they have different values. So this quadrilateral, it doesn't possess any specific property. So this is a simple quadrilateral. But when a quadrilateral attains certain properties, it is named differently as well as its shape appears different. So basically, quadrilateral is classified into three main categories, as you can see here. The first category is trapezoid. You will also call this as trapezium. That's how you know it. The second one is called as a parallelogram, and the third one is called as kite. Trapezoid can be further classified into isosceles trapezoid, what we also call as isosceles trapezium. Parallelogram can be divided into three main quadrilaterals. The first one called as rhombus, the second one called as square, and the third one is called as a rectangle. So as of now, keep this in mind that a rhombus is actually a derivative of a parallelogram. It is obtained from a parallelogram. A rectangle is also obtained from a parallelogram. A square is also obtained from a parallelogram. That means all those properties that a parallelogram possesses will also be present in rhombus, will also be present in rectangle, and they will be also present in square. Similarly, since an isosceles trapezium is obtained from a trapezium, that means all the properties of a trapezium will also be present in an isosceles trapezium. Let's further have a look at their definitions. So these definitions I already sent you yesterday. So first up is quadrilateral. A closed figure made up of four sides is called as a quadrilateral. So it is self-explanatory that a closed four-side figure is called as a quadrilateral. So it doesn't have any properties. That's why there isn't any special about it. But as soon as you go down, you will find that it attains properties and the name is not just now quadrilateral. It has different names now. First up is parallelogram. A quadrilateral whose opposite sides are parallel is called as a parallelogram. Keep this in mind that this is the most important point of all, that sides are parallel. So if you have a simple four-sided figure in which sides are parallel to each other, both the sides, opposite sides are parallel to each other, it becomes parallelogram. Here I want to clear a confusion. Usually students remember that a quadrilateral whose one pair of opposite sides is equal and parallel is called as a parallelogram. No, that's not the definition. That is actually a property of a parallelogram that we will study later. But first of all, remember this. A quadrilateral becomes parallelogram when its sides are parallel to each other. So the very important thing is that, for example, if you have a question where you have to prove a quadrilateral is a parallelogram, how are you going to do this? You are going to show that the sides are parallel to each other, and when sides become parallel to each other, the quadrilateral is called as a parallelogram. Next one, rectangle. You can clearly see the difference over here. For defining parallelogram, I said that a quadrilateral, but when I have to define a rectangle, I said a parallelogram. That means a rectangle is not a simple quadrilateral. It already has all the properties of a parallelogram. keep this in mind. We will further understand in the properties section. So rectangle is a parallelogram. So all the properties of this parallelogram are present in here with one of the angles equal to 90 degree. So what is the specific property? This one. You have to keep in mind these specific properties, because when you are going to give proof, when you are going to do the exercise or the proof of the theorems, these are the specific points you will require. Keep this in mind, this 90 degree. So in a parallelogram, if one of the angles become equal to 90 degree, the parallelogram is called as a rectangle. As per the definition, let's say there is a question, it is given as a parallelogram and you have to prove that it is a rectangle. What will you look for? What will you prove there? Yes, you will prove that one of the angles is 90 degree. Keep that in mind. So this 90 degree is your key point here. This is a very important thing here. So a rectangle, a parallelogram with one angle equal to 90 is called as a rectangle. This is all you require to make it a parallelogram. Sorry, rectangle. Next up is a rhombus. Again, you will see that we say that a parallelogram. So rhombus is also a parallelogram. All the properties of a parallelogram will be found in a rhombus. A parallelogram whose adjacent sides are equal is called as a rhombus. So if you have a parallelogram whose adjacent sides are equal, you will call this as a rhombus. So let me say I have a parallelogram here. In this parallelogram, this side and this side, they're called opposite side. This side and this side, they're called as opposite side. While as this side and this side, they're called as adjacent sides. This side and this side, they're called as adjacent sides. Similarly, this side and this side, they're called as adjacent sides. So a parallelogram whose adjacent sides are equal is called as a rhombus. That means if you have a parallelogram and in that parallelogram adjacent sides are equal, let me draw this parallelogram, and in this parallelogram these adjacent sides are equal, this and this, just one pair. You don't need to prove all. If you can prove that just one pair of adjacent sides are equal, it turns out to be a rhombus. So let me say that there's a question where it said that a quadrilateral is there, prove that it's a rhombus. So how will you prove it? You will do this in two stages. First, you will prove that the quadrilateral is a parallelogram. Then you will show that parallelogram has adjacent sides equal, and it will give you, yes, exactly, it will give you a rhombus. So here the keyword is adjacent sides are equal. So if you have to prove a parallelogram is a rhombus, what you have to prove? Adjacent sides are equal. Not all, just prove one, and it is enough to prove all the adjacent sides are automatically equal. Next up is a square. So it is square now. A parallelogram with one of the angles equal to 90 degree and having adjacent sides equal is called as a square. So here you have to look for two things. First up is you have to show that the one of the angles is equal to 90 degree, and you have to also show that adjacent sides are equal. Isn't it we just did? This property was for a rectangle and this property was for a rhombus. That means a square is actually a combination of both a rectangle as well as a rhombus. So if you have to prove a parallelogram is a square, you have to prove that it has both the properties of a rectangle as well as a rhombus. That is, one of the angles is 90 degree and also it has one pair of adjacent sides equal. Let's say there's a question. You have been given a quadrilateral and you have to prove that the given quadrilateral is a square. How will you prove it? First, you will prove that the given quadrilateral is a parallelogram. Then you will prove that one of the angles of the parallelogram is equal to 90 degree. Then you will also prove that one pair of adjacent sides is equal. And this is how you will convert this into a square. So what are the keywords here? 90 degree and adjacent sides equal. Keep this in mind. Next is a trapezium. Again, you can see that I didn't wrote here a parallelogram. I wrote here a quadrilateral because trapezium is not related to a parallelogram. So it is a quadrilateral. A quadrilateral whose one pair of opposite sides are parallel is called as a trapezium. That means it is such a quadrilateral in which not both pairs are parallel like parallelogram. Rather, just one pair of opposite sides are parallel. So it is called as a trapezium. You are well aware of its figure, how it looks like. We usually draw it like this. Yes, we usually draw it like this. This is a trapezium in which this side and this side, they are parallel to each other. Next up is isosceles trapezium. Uh, it is very simple. If these two are parallel sides, then what about these two sides? What will they called? Yes, they're called as non-parallel sides. And a trapezium in which non-parallel sides are equal. That means a trapezium in which these two sides, these non-parallel sides become equal to each other is called as an isosceles trapezium. Understood this? Isosceles trapezium is a trapezium, but it has some additional properties in it. And what are those properties? Those properties are that its non-parallel sides become equal to each other. Next up is a kite. A kite is a quadrilateral whose two pair of adjacent sides are equal in length. So it is again not a parallelogram, not a part of parallelogram, not a derivative of parallelogram. Rather, it is a simple quadrilateral. And what is in this quadrilateral? In this quadrilateral, there are two pair of adjacent sides equal. Let me draw it first. We draw a kite like this. Okay. Now, we know that this side and this side, they are adjacent sides. This side and this side, they are adjacent sides. Similarly, this and this, they are also adjacent, and others are also adjacent. So, it says that only two pair of adjacent sides are equal. That means not all adjacent sides are equal. Just two pairs are equal. Which two pairs? This side and this side is equal in a kite. This side and this side, let me draw double lines to differentiate them, are equal in a kite. So that means in a kite, these two adjacent sides are equal and these two adjacent sides are equal. So a quadrilateral in which two pairs of adjacent sides are equal is called as a kite. Next up is this chart over here, in which I have drawn the shapes of all these quadrilaterals and also written properties in there. Quadrilateral, it has four sides and sum of interior angles is a 360 degree. You have learned this, that sum of the four angles of a quadrilateral is 360 degree, also called as angle sum property. Then there is a parallelogram in which both pair of opposite sides are parallel, both pair of opposite sides are congruent, or you can also call it as equal, both pair of opposed angles are equal, and there are other properties. This I have given you so that it becomes easier, that all the figures as well as properties are available in a single chart. You can print it out and you can keep it with you. For understanding the properties, we will move on to the next slide. These are the properties over here. First up is a square. A square is a regular quadrilateral. You have learned in your class 8th, regular quadrilateral means all the four angles are equal as well as all the four sides are equal. That means this side, this side, this side, this side, they are all equal, as well as this angle, this angle, this angle, and this angle. All the four angles are equal. That is written over here. All angles are equal to 90 degree. The second property is mentioned that all sides are of equal length. All the four sides have the same length. Opposite sides are parallel. Do you remember where this property comes from? Yes, this property comes from parallelogram, because square is a parallelogram. Parallelogram has opposite sides parallel, so this also has opposite sides parallel. Now, diagonals bisect each other at a 90 degree. Uh, the bisection property, that is diagonals bisect, this property comes from parallelogram. But they bisect each other at 90 degree. This property is unique for a square over here. That whenever two diagonals, these are his two diagonals, they intersect each other, the first thing they do is they bisect. Bisect means dividing into two equal halves. That is, this part is equal to this part. So the diagonal is getting bisected into two equal halves, as well as uh, this part and this part of the diagonal, they are also equal to each other. This is called as bisecting, that is dividing into two equal halves. That means, keep this in mind, diagonals of a square bisect, and this property comes from parallelogram because the diagonals of parallelogram also bisect each other. Next property is the diagonals are equal in length. Also a unique property of square, that its diagonals are equal in length. That means they have the same length. So that means the distance from here to here, that is this length, is exactly equal distance from here to here, equal to this length. So the length of the diagonals is equal. This can be also stated as diagonals are equal in length. These are the properties of a square. Next up is a rhombus. First is diagonals, opposite angles are equal. You can simply call this as opposite angles are equal. Again, this property comes from parallelogram because in a parallelogram, opposite angles are equal. That is, let's see in the figure where opposite angles, this angle and this angle, they are opposite angles, so they are equal in a rhombus. Keep this in mind, they are actually equal in a parallelogram, and since rhombus is a parallelogram, that's why they are also equal in a rhombus. And this angle, they are equal. This is stated as opposite angles are equal. Second property, all sides are of equal length. In a rhombus, all the four sides have the same length. That is, this side, this side, this side, this side. Somewhat like square. Square also had all the four sides equal. Rhombus on now here also has four sides equal. But square had all the angles equal to 90 degree. Rhombus doesn't have. It only has opposite angles equal, and all the angles are not equal to 90 degree. Second property is, the fourth property is opposite sides are parallel. Yes, you remember this property, where this comes from. This property comes from the parallelogram. Opposite sides are parallel because rhombus is a parallelogram. So all the properties of parallelogram automatically come in a rhombus. So opposite sides are parallel in this parallelogram. So they also come in a rhombus. And the last property is diagonals bisect each other at a 90 degree. I have just made you understood what bisect means. Bisect means this part and this part is equal. This part of the diagonal and this part is equal. Basically, you can see that this center point is dividing the rhombus, dividing the diagonals of the rhombus into equal halves. So diagonals bisect each other, not just bisect, they bisect each other at 90 degree. That means the angle in here is 90 degree. Over here, where the two diagonals cross each other, they cross each other at 90 degrees. So it is 90 degree over here. So these are the properties of a rhombus. Next up is rectangle. In a rectangle, all the angles are equal to 90 degree. If you remember about the definition, the very first requirement for a parallelogram to be rectangle was that one of its angles should be 90 degree. So I wrote down all angles are 90 because when one angle becomes 90 in a parallelogram, all other angles automatically become equal to 90 degree. Second is opposite sides are of equal length. Again, remember this, where this property comes from. This property comes from parallelogram because in a parallelogram opposite sides are equal. So that comes in the rectangle because rectangle is actually a parallelogram. So this side and this side, they are equal in length. This side and this side, they are also equal in length. And the third property is diagonals are equal in length. That means the distance from here to here and the distance from here to here is exactly the same. Diagonals are equal in length. Next is parallelogram. It was basically actually it is that very quadrilateral whose properties are found also in square as well as in rhombus as well as in rectangle. Diagonally opposed angles are equal, or simply you can call it opposite angles are equal. Remember where we saw this property? Yes, we saw this property in a rhombus, but this property is also in square as well as in rectangle. Opposite sides are of equal length. Yes, we saw this property in rectangle, but this property can be stated also for rhombus and also for square. Opposite sides are parallel. That is the basic requirement for a parallelogram, and the diagonals bisect each other. We found this property in square as well as in rhombus as well as in a rectangle. This bisection property, that the diagonal divide each other into equal halves. That is, if this is considered the center point, then this half and this half is equal. This half and this half is equal to each other. Next up is a trapezium. In a trapezium, one pair of opposed side is parallel, and that is this side. These two sides are parallel to each other. Parallelogram, both the sides, opposed sides are parallel, while as in trapezium, just one pair of opposed sides is parallel. And what if we have to convert this into an isosceles trapezium? In an isosceles trapezium, this side and this side should be equal to each other. As you can see here, they are not equal. So this is just a simple trapezium. But if you have to convert this into an isosceles trapezium, then this side and this side should be equal to each other. And isosceles trapezium has different set of properties that we are going to discuss later in the chapter. Next up is kite. Two pair of sides are of equal length. I just said that there are two pair of adjacent sides that have the same length, and it is denoted over here. This side and this side, they have the same length. This side and this side, they have the same length. Two pair of adjacent sides have the same length. One pair of diagonally opposed angles equal. In a kite, this angle and this angle, they are equal. Just one pair of opposite angles are equal. Like in a parallelogram, both the opposite angles are equal. In a kite, you have just one pair of opposite angles equal. Only one diagonal is bisected by the other. We also call this in this manner, that the larger diagonal bisects the smaller diagonal. So if I consider this as my larger diagonal, this one I consider my larger diagonal, and this I consider my smaller diagonal, then this larger diagonal bisects the smaller diagonal into equal halves. So these two parts are equal to each other, and that was a kite. Hopefully you understood it.